Hey, Mr. Nelson, your room's coming together pretty good. What are you up to?
Oh, I'm just taking a break.
Oh, well, what are you eating?
Oh, just some gummy bears. Would you like one?
Ooh,
you want
gummy bear.
another one?
Yeah.
Oh, shoot.
What happened?
Oh, a gummy bear landed in my water.
Weird. What do you think will happen if we left it there?
Oh, you don't want to get it out?
Oh, I don't know. I'm kind of curious. I mean,
I
it already looks interesting in there. Can you see that?
Well,
What do you think would happen if, say, we left it overnight?
I don't know. Let's find out.
I'm really excited to see what's going to happen with our gummy bear.
I am too. But as a scientist, we probably should take some measurements of a gummy bear before it's in water so that we have something to compare the changes to when we pull the gummy bear out of the water tomorrow.
That's a really good idea. What kind of measurements do you think we might need? Like length?
Yeah, I think we should probably take the length, the width, and the height.
Ooh, what about the weight?
Science, we measure weight in mass.
Oh, like grams. So we're gonna definitely wanna mass that. Anything else that we maybe need to think about?
Well, if we have length, width, and height, we can calculate the volume of the gummy bear.
Ooh, that sounds like a really good idea. So if we calculate it before and then we leave it in all night long, we can see how the gummy bear changed over time. We've got the gummy bear lined up really nice and neat so we can be accurate to measure its length. You can see its little feet are lined up at the 0 centimeter mark. And if you look really carefully, you can see his little ears. They go to the first line past the 2 centimeter mark. So we could say that the gummy bear is 2 centimeters and 1 millimeter in length, or we could say that the gummy bear is 2 1/10 centimeters in length. So then when we turn the gummy bear and we are looking at its width here, you can see that one foot is lined up with that 0 centimeter mark, and the other little foot, if you look real close and careful there, you can see that it goes one line past the 1 centimeter mark. So again, we would say that the gummy bear is 1 1/10 centimeters wide, or we could say it's 1 centimeter and 1 millimeter wide. We need to measure the thickness, is what I'm going to call this one, of the gummy bear. And so when I look really carefully, I've got his little foot lined up with the 0 mark, and if I look carefully at that, I believe that there's about 8 little lines. So I could say that it is 8 millimeters thick, or if I want to stick with my centimeter measurements, I would say that it's 8/10 of a centimeter. While I was giving those measures, Mr. Nelson was writing them all down. And next he's going to help us understand how we calculate the volume.
Okay. To find the volume of our gummy bear, we're going to take each of our measurements, the length, the width, and the thickness, and we're going to multiply those together. When I multiplied those together, I got 1 848 thousandths. I really don't need to be that precise. We've already been measuring in tenths, so I'm going to round this to the nearest tenth. And so when I round that to the nearest tenth, I get 1 8/10 cubic centimeters. To find the mass of our gummy bear, we're going to use a digital scale. We're going to make sure that our digital scale is set to measure in grams, and this one is. So I'm going to go ahead and put the gummy bear on our digital scale. And you can see that it shows our gummy bear is 2 43 hundredths of a gram. Just like before, we've been measuring to the nearest tenth, so we're going to go ahead and continue with that. So our mass of our gummy bear, we're going to round to 2 4/10 grams.
So, you know, we had an accident with the gummy bear falling into the water, but in order to kind of be actual scientists, we probably need to standardize this process. So I see here you've got a unit of measure for our water.
Yeah, I've used a graduated cylinder to measure out 25 milliliters of water, and every time we conduct this experiment, we'll always use the same amount of water. So we'll go ahead and put this in our container, and I'll put the gummy bear that we've been measuring into our water. I'll put a lid on that, and we will let this gummy bear sit overnight, and then we'll take some identical measurements tomorrow so we can see how our gummy bear has changed.
Hey, Mr. Nelson. Yesterday we left our gummy bear in that water so that we could see what would happen to it. Are you ready to check it out?
Yeah, I'm really excited to find out what happened.
What do you think happened?
It's hard to say, but if I had to make a prediction, I think maybe the gummy bear would absorb some of the water, so I think it maybe grew and got a larger volume. What do you think?
Nah, I bet it stayed about the same. I bet there was no change.
You don't think it changed?
No, I mean, the outside of the gummy bear is kind of like firm, you know?
Okay.
So why would it change? But let's go find out.
Okay.
All right, here we are back at our gummy bear. I'm just going to take the lid off today. And oh my gosh, look at that, Mr. Nelson. Do you see that thing? Like, it lost some of its color and it's pretty poofy. We have our gummy bears, and we put a similar unsoaked gummy bear here next to the one that we had put in the water yesterday so that you could really visually see the difference and how much it grew. And the ruler's up next to it, and so we're going to take that really accurate measure again, and if I were looking at that very carefully and closely, I would say that it is 3 6/10 of a centimeter. So when I look really closely there, it's past that ½ centimeter mark on its length. And then when we measure its width, I would say that that is 1 9/10 centimeters. So again, measuring accurately to the nearest 10th centimeter. In order to get an accurate height here of the gummy bear, I'm having to hang it off the edge of the counter because the zero is not on the very edge of this particular ruler, so that I can get that really accurate measure of its height. And I'm gonna say that that is 1 7/10. The last thing we need to do is mass the gummy bear. And when we mass the gummy bear, we get 8 37/100, or we're gonna round to the nearest 10th, 8 4/10.
Okay, I took all the measurements that Miss Vilsack gave me, and I calculated the difference to see how much the gummy bear grew. I did that by subtracting the numbers from day 2 minus the numbers from day 1. And the gummy bear grew in length by 1.5 centimeters. It grew in width by 8/10 of a centimeter, and the thickness grew by 9/10 of a centimeter. But when you do all those calculations, the volume increased from 1.8 to 11.6, and our mass increased from 2.4 grams to 8.4 grams.
All right, well, that was really fun to see what happened when we put the gummy bear in water, but it got me thinking. What would happen if we put it into other kinds of liquids and let it sit overnight?
You know, that's a great question, Ms. Vilsack. And honestly, that's what science is. Once you have your first question and you get some results, that's going to lead us to another question and more investigations of things that we want to try and find out.
Man, science is cool. Hey, Mr. Nelson, do you think we can get the gummy bear to shrink back to normal size?
No.
I kind of want to find out.